Okay. When we are talking about differential equation, I said is a equation that deal with relationship between x and y. That's dependent variable. Now, back to the basic law of like function of differentiation. We have y is a function of x, and I said if you're having this case, this our y is dependent variable, dependent dependent variable, and this place is independent. Independence for the fact that it can stand alone without attaching to anything. Now, if we are not talking about dependent variable, so this is what differential equation now say that is the relationship between the dependent variable y and independent variable x with differential coefficient. Now, what did they mean by differential coefficient? I explained last class. I said differential coefficient means the y over the x or the m over the p. You understand? Like maybe a derivative. You understand? With the function, maybe in this case, you are going to have the y with x because it's your y with x now. Now, it's different from now. Differential is now different from differential equation. But differential equation almost related with integration. What does that mean by that? If you have y is equal to 2x, as I said last class, or 2x squared, if you differentiate this, you have what? Y is equal to what? 4x, right? Now, if okay, dy dx, right? Dy over the x is now 4x, right? But if we are not want to move from this position, you know, you come from here to here. If you want to come from here to here, you integrate. So this is where differential equation now starts like dy. We make where you see x to be together is going to be what? 4x what? Dx. You get this now? With everything that's going to be here, the derivative of it with the function of x. So the next thing to do, you now integrate both sides. So with the fact that this will cancel this, you have y is equal to, if you want to integrate, as I said, you are going to add 1 to the power. You know the power here is 1 already. So you add 1 to the power divided by the power, which is 1 plus 1. So you have 4x squared over 2 plus c. So anytime you are integrating without having a boundary, you are going to be adding c. But if there is a boundary condition, which maybe from 0 to 1 or 0 to infinity or minus infinity to something, you are going to apply the boundary, there won't be c. So in this case now, this c now represents your constant that is here. You know, in your function, you have what? Okay, if you now break it down, you have y is equal to what? 2x squared plus c, right? It's almost the same thing with this. But only difference that is there is this plus c. But this plus c is having a meaning. It says the situation whereby you have plus 3 here. You know, if you differentiate this 3 is 0. So it's the same thing now with this. So this c is now representing this 3 that is there. So that's differential equation. But we now have a different method of solving it. I said the direct integration. What is that direct integration means? I said if you're having the y over the x is equal to a function of x, you are going to apply direct integration. I said that last class. So what does that one mean? If you have the y over the x is equal to exponential 3x. You know, this dy is a function of x only. There is no anything attached to it or something. So in this case, our dy is equal to now exponential what? 3x what? Dx. The next thing is what? Integrate the both sides. If you integrate this one, we eliminate, you have what? Y is now equal to what? Let's integrate this. According to the law of integration, when you are dealing with exponential function, if you have, you know, let me go back to differentiation. If you have y is equal to exponential 2x, if you want to differentiate this, you will differentiate the power here. You're having what? 2. So you have dy over the x. You now be what? 2. That's the first thing. Differentiate the up. You are dealing with differentiation now. Are you guys together? So you differentiate this up, you have what? 2. You write the function, which is what? Exponential 2x. Now, it's the same approach you want to apply to this, but only different on integration that in the situation whereby you are multiplying with it, you'll be dividing in this case. Do you get this? So in the end, if you want to integrate this now, you have what? Differentiate this up, you have what? You have what? 3, right? So you're now going to be exponential 3x over 3. Because what I said is that you will differentiate by the denominator plus what? Plus c. So in this case, that's your derivative. What I'm explaining is what? The direct integration, right? So we have the direct integration. Number 2, I said it's for you to know the difference between them. They can ask you that question. Go back to the last class. If I explained the order, the power, no, power or degree. So I said the order is that if you are your order of differential equation depend on the derivative of your function. Now last class I said if you have dy over dx plus 2x is equal to 3. Number one, understand when it's linear, understand when it's non-linear. We have linear differential equation, we have non-linear differential equation. Let's say with 3y. For you to know if it's linear or non-linear is that it's going to be y without having any power of 2 or more than 1. If your function, if your y in the situation where you're having with together with y here in this case, the power must not up to like 2. Maybe you have y squared. Anytime you're having y squared in your function, it's non-linear. Or y raised power 3, y raised power 4, or something like that is non-linear. Number one. But in this case, it's a linear. That's number one. Number two, what type of order is this? Because the highest power of y here is what? Is 1. Is linear. So our other case is that the order, as I said last class, it depends on your derivative. If you are having dy dx is first order. First order. If you are having the square y over the x square is what? Second order. Continue like that. If you have the cube y over the x is what? Third order. Now imagine if you are now add this, the square y over the x cube plus d. Now let me go back to what I'm trying, because there's a case that you are going to write the differential equation that's going to convince you. If the order depends on the highest power of your differential coefficient, highest derivative, are you getting it? Kò mí èyí tó bá ṣáájú or èyí tó bá parí, what matter is the highest derivative. Now let's have this example: the cube y over the x cube plus the cube the fourth y over the x 4 plus 3x is equal to y. Now in this case, what type of the order is this? How many order, like the order of this differential equation is what? Is fourth order. Why? Because the highest derivative of your differential coefficient is what? Is 4. Èyí tó bá ti ní highest lè máa focus lórí. Now because this one is not matter, they are still under it, so the highest is what? 4. Number 2 is a linear. What? Because there's nothing like this. There's nothing like the power of this. Is a linear first order and degree of 1. Are you getting? The degree is the same thing as power. Now let me give you another example, because in this case only convincing your girl. Now let's say we have the cube y raised power, okay, the cube y over the x cube raised power raised power 5. So raised power 5 plus x cube is equal to y raised power 3. Okay, what type of order is this? Is it first order? Is it second order? Is it fifth order? Is it seventh order? Is it ninth order? Is it 10th order? Is what? Third order. Yeah, thank you so much for that. It's third order. You know, they wrote this power 5. That one doesn't matter. It's your degree. We call it degree or power. Are you getting it? So it's degree of 5 or power of 5, and the order is what? 3, because the highest power. For me this one doesn't mean that dy over dx is now the cube y over dx cube is now raised power 5. Like imagine the 15y over no. The main thing is this. It's just the power of this one. So which means everything here is having the power of this one. But it's not mean that there's a difference between 2 raised power 2 and 2 plus 2 raised power 2. Are you getting this? There's a difference between them. Now go back to this case here. And is it linear or non-linear? Non-linear. So that's that on that. So I've explained the first step, which is what? Direct integration. I just try to recall from the last class for those that are not in class. Now let me the second one is what I said. We have 5 ways of solving this. You have the direct integration, you have separation of variables. So that separation of variable is if you're having the y over the x with a function of s comma y. So is that all? dy over the x multiplied by maybe function of x dot g of x. So in this case, if you're having your x, your dy dx is a function of x and y, maybe they are multiplying each other. So the right way to solve this is using this thing. So let me using separation of variables. Now let's say example, maybe you have the y over the x is now equal to, or is equal to f of x. Let's put equals to here. It's equal to f of x comma y, or the y dx equals. So in this case, you have x plus 2 is bracket x or y plus 2. So in this case, the right way to solve this is using the separation of variables. I'm just recalling from last class for those that are not there. So the separation of variable y, for you, if there ever any question, if I saw any question, I know the method to solve it. Because look at this case, is really representing this function I'm having here. We're having the y ds is there. So a function of x multiplied by g of y. So it used to be g of y. Function of x comma y. Do you get that now? So look at this case. This is your f of x because it's only x that contain here, and this is your g of y because it contains y. So the next thing to do here is that make sure find a way that x will be in one side with derivative of x, and y will be in one side with derivative of x. In this case, you can do something by dividing by what? Y plus 2, right? Come to this place too. Or let's do this place. Multiply both sides by dx. So dx. So we have the y will now be what? X plus 2, y plus 2, what? Dx. The next thing, divide both sides by what? By y plus 2. So you have what? Y plus 2. This one we eliminate this. We have dy over y plus 2 will now be equal to x plus 2 dx. So in this case, the next thing to do is what? Integrate both sides. After you separate them, the next thing to do is to integrate. So you have integral, like you have integral of 1 over y plus 2 dy will now be integral of x dx plus integral of 2 dx. I explained last class that if you're having integral of f of x plus or minus g of x is equal to f of x plus f of x comma y will now be equal to plus or minus, now be equal to integral of f of x dx plus integral of g of y dy. This is what I'm trying to say here, is that if you're having a function of y and x adding each other, the best way to solve this is that integrate with the first one, if it is positive or negative, and integrate the second one, positive or negative. Same thing I did here. Come to this side, you're having integral of x plus 2, right? So integrate this one with what? X, and integrate the second one, dx, with this one. So it's like you're just taking them one after the other. That's the addition rule. So the next thing here is that what? Let's continue from here. So if you integrate 1 over y plus 2, before you can, anytime you're having a fraction, the first thing should come to your mind is that find a way to differentiate the denominator. If we give you the numerator, it's the length of the denominator. Are you getting this now? So look at this place. You're having what? Y plus 2. If we differentiate y plus 2, what are we having? Let's assume you are differentiating. You're having what? You're having what? 1. Why? Because this 1 is power 1 with dy. Are you getting this now? You are differentiating this with what? Dy. So it's going to be what? 1 y raised to power 1 minus what? Minus 0, right? So over what? Multiply by what? 1 minus back to integration differentiation. If you have 1 as the power, you multiply it with this. You have what? 1 y minus 1 from the power 1 minus 0. So because this one is constant, it turns to 0. So here you have what? 1. Do you get this? Because this one's y is power 0. 1 minus 1. Sorry. 1 minus 1. Well, this one is power 0. Anything is power 0 is 1. So in this case now, this one, the denominator, if you differentiate this denominator, is not the same thing with the numerator. It's now what? The length of the denominator. So in this case, you are going to have length y plus 2 will now be what? If you differentiate, integrate x, you have what? Integral of x 1 plus 1 over what? 1 plus 1, which is equal to what? X is power 2 over 2. In this case, you are now going to have what? X is power 2 over what? Over 2 plus, anytime you are even differentiating with your, you are differentiating integrating a constant. This one we just cancel this. You have 2 times x, you have 2x plus what? 2x plus what? Plus c. Do you get that now? So the next thing you can do here is that you can leave your answer in this case, but you can still try to eliminate the exponential function. So you can take the exponential of both sides, take exponential of both sides. So we have exponential ln y plus 2, you know what? Exponential x squared over 2 plus exponential 2x plus. Now if you are multiplying with exponential, unless if you are dividing exponential, so let me just explain here. Yeah, exponential of c. Do you get this now? So this case, exponential will cancel ln. Are you getting this? Ln will cancel exponential. We have what? Y plus 2 plus exponential what? X squared over 2 plus exponential 2x plus c. Anytime you are multiplying with a constant or anything, you are having that c back. So the next thing you can do here, just take these 2 here to find your final answer. So you have y is equal to exponential x squared over 2 plus exponential 2x minus 2 plus c. You can leave your answer in this way. So that's just that on separation of variable. Just little thing we are doing in this case.